Hello and welcome, students. My name is Shampa. Today we are going to study a very interesting topic in mathematics called exponents. So let's begin. Now just have a look at these numbers. They are actually so inconvenient to read. In order to simplify them, we use the concept of exponents. Let's understand what are exponents. Let's take an example of a simple addition. Here we have added 7 quite a number of times. Let's see how many times. 1, 2, 3, 4, 5, 6, 7. Let's add it one more time. Okay. So we have added 7 8 times. So how do we write it? We write 7 into 8 is equal to 56. Now just imagine if we multiply 7 like this 8 times. 7 into 7 into 7 into 7 into 7 into 7 into 7 and one more 7. So in this case we use exponents. In such a situation we use exponents to represent this number. We have multiplied the same number several times. So the number that is being multiplied several times is expressed as a base. Like in this case, 7 is the base and the number of times we have multiplied the number is expressed as the exponent. We can also call it 7 raised to the power 8 or the 8th power of 7. So let's move on. Let's take the example of some more numbers to understand the concept. Let's say we have 5 to the power 4. How are we going to find the product? This is actually 5 multiplied 4 times. So here we have 5 into 5 into 5 into 5. This is going to be 625. And what do we actually call this number? This is called 5 raised to the power 4, or we can also call it the 4th power of 5. And the result is 625. Let's do a few more examples. Now what if it's a fraction? Say it's like this. In this case, 2 by 7. The entire 2 by 7 is the base and 3 is the exponent. 2 by 7 raised to the power of 3. And how are we going to express it? We are going to express it like this. 2 by 7 into 2 by 7 into 2 by 7. So we will multiply the denominators and then we will multiply the we will multiply the numerators and we will multiply the denominators. So we will get 8 by 343. Now just remember one thing, very important. Whenever we write 2 by 7 raised to the power 5, this exponent to the power 5 is shared by the numerator and by the denominator. If this power only applies to the numerator or to the denominator, then this bracket would not have been there. If this exponent was only on the numerator or the denominator, we would write it like this. It was 2 by 7. Or maybe like this. If it is on the denominator, so if we are putting a bracket enclosing the numerator and the denominator, then this exponent is shared both by the numerator as well as the denominator. Let's move on. Now what if we multiply some negative numbers? Let's say minus 2 into minus 2 into minus 2 into minus 2. what would happen in this case? No need to worry. We know that when we multiply integers and when they have a negative integer multiplied to a negative integer results in a positive integer. Let's recall the concept of integers and let's work it out together. And then a positive integer being multiplied to a negative integer, result will be a negative integer. And then we will multiply this negative integer to this negative integer again. We will get a positive integer. So always remember one thing, whenever you see a number like this, just count how many times they are being multiplied. And then if it is even number of times, the sign of the product is going to be positive. If it is odd number of times, the sign of the product is going to be negative. In case all the bases that we are multiplying, in case they are all negative, it's only applicable in this case when all the signs are negative. Let's understand it with the help of examples. Let's say we have minus 1 into minus 1 into minus 1, say 51 times. Now in this case, we are multiplying minus 1 with each other and we are multiplying it 51 times. So minus 1 is the base and exponent is 51, which is an odd number. In this case, the result is going to be negative because 51 is an odd number. And the answer is going to be minus 1. Let's take one more example. Let's say we have minus 2 into minus 7 into minus 2 again, minus 2 again, and then minus 7. What are we to do in this case? Just separate the numbers which are the same and group them together. Like we have minus 2 3 times. So we can write it minus 2 to the power 3, and we have minus 7 2 times. So we can write it like this. Let's work it out. Minus 2 to the power 3. Now 3 is an odd number. So the base is a negative number and the exponent is an odd number. So the sign of the product is going to be a negative number. And 2 to the power 3 is 8. And let's take the example of minus 7 raised to the power 2. This minus 7 is also a negative integer, and but the power, the exponent part, is even. So in this case, the answer is going to be positive and it's going to be 49. I wrote positive sign here because it is the sign. It doesn't mean that 8 multiply plus 49. Let me write it clearly. Minus 8 into 49. So this is going to be minus 392. So let's move on to our next section. Now look at these numbers. We have 10, we have 100, 1000 and 10,000. What is 10 actually? It is 10, and if we factorize it, it's actually just 10 into 1. What is actually 100? What are the factors of 100? It's 10 into 10. Similarly, 1000 has factors 10 into 10 into 10. Same is the case with 10,000. So here we see that we have not multiplied 10 with any number, so it's just 10 to the power 1. Here we have multiplied 10 twice, so it's 10 to the power 2. Here it is 10 to the power 3, and here it is 10 to the power 4. These figures with a base of 10 are very useful in physics when we express the size of, when we convert something in terms of micrometer or nanometer or femtometer. These figures are useful there. Also useful when we express astronomical units. There it is not possible to write the number in a linear fashion. It becomes very lengthy, like if we write the speed of light in 1 year, how would we express it? Now, all of us know the speed of light is 3 lakh kilometers per second. It is 3 lakh kilometers per second. But what would be the speed in 1 year? In 1 year, it's going to be something 9460.5 billion kilometer. This is a huge number. We have to express it in terms of exponents to make it convenient for us and to make it readable. Let's move on. Now we know the speed of light is 3 lakh kilometers per second. We can also write it as 3 So how would we read it now? 3 into 10 crore. So we can write it conveniently like this. 3 into 10 to the power 8 meters per second. It looks decent and it is convenient too. Now let's move on to some more examples based on exponents. Now let's work on some examples to make the concept of exponents a bit more clear. We have 7 raised to the power 2. It simply means 7 into 7, which is 49. We have 9 raised to the power 3. It means 9 into 9 into 9. And this is going to be 729. 11 raised to the power 2. 11 into 11, which is also called, whenever there is a power of 2, we call it the square of the number. So the square of 11 is 121. And one thing more, whenever there is raised to the power 3 on any number, we call it the cube of the number. So these are special names assigned to the exponent of 2 and exponent of 3. Whenever the exponent is 2, we call it the square of the base. And whenever the exponent is 3, we call it the cube of the base. Let's move on. We have 5 to the power 4. So we can write it as 5 into 5 into 5 into 5. This is going to be 625. Let's understand the concept clearly by taking the help of some negative numbers. Let's find the exponent of those negative numbers. Now let's say we have minus 2 raised to the power 3. So minus 2 into minus 2 into minus 2. It's going to be minus 8. Also, I told you one thing more, that whenever there is a negative base and the exponent is an odd number, in that case, the sign of the product is going to be negative. And we will solve the question accordingly. We will solve it the way we do it. The only difference is we will check if it is a negative number and the exponent part is an odd number. In that case, the result is going to be negative, and we will find the result of this minus 2 raised to the power 3 the way we normally deal with the positive exponent. So it is minus 8. We have minus 7 raised to the power 2. So minus 7 is a negative integer, but the exponent is positive. So the result is going to be positive, and it is 49. We have minus 1 raised to the power, minus 11 raised to the power 2. The result is again going to be positive because the exponent is an even number. So it is 121. Minus 9 raised to the power 3. The base is a negative number and the exponent is an odd number. So the sign of the product is going to be negative. Let me repeat myself. Whenever there is a negative integer and there is an exponent over that negative integer, always check if the exponent is odd or if it is even. If the exponent is odd, the result is going to be negative. If the exponent is even, the result is going to be positive. And then this way you can determine the sign of the product, and then you can find the product as usual. Let's move on to our next section. Now let's simplify. So we have 7 into 10 to the power 5. Let's simplify it. 10 to the power 5 can be written as 1 lakh. So it is 7 lakh. Now we have 7 to the power 2 into 3 to the power 2. Let's work it out. 7 to the power 2 is 49 and 3 to the power 2 is 9. So we have 441. Let's take one more example. Let's take minus 3 to the power 3 into 5 to the power 2. It's a negative base and an odd exponent. So the sign of the answer is going to be negative. So we have minus 27 into 25, which is going to be minus 675. Now let's work on exponents with some rational numbers. Let's say we have 2 by 5. So we have 2 to the power 2 by 5 to the power 6. Here both are the numerator as well as the denominator are positive integers, so we need not worry. And as I told you, this exponent will be shared by the numerator as well as the denominator. So 2 to the power 6 is going to be 64 and 5 to the power 6 is going to be 15,625. Let's move on to our next section. Now let's work out these examples together. So we have minus 3 into minus 2 raised to the power 3. So leave minus 3 as it is for the time being, and minus 2 raised to the power 3 is going to be minus 8. So the result is going to be 24, because this minus sign, when we add two negative, when we multiply two negative integers, the result is a positive integer. We know that. Let's move on. This is a negative base but an even exponent. So Here is also it is the same case. We have 9 into 25, which is going to be 225, positive 225. Here we have minus 2 to the power 5, which is minus 32. And here also it's a negative base and an odd exponent, which is going to be minus 1000. So we are going to get positive number. Get a positive number. We are going to get 32,000. Here we have minus 2 raised to the power 4, negative base, even exponent. It's going to be 16 into, again negative base, even exponent, 25. So 16 into 25 is going to be 400. Here we have a rational number. Let's do it. Minus 3 raised to the power 3 and 4 raised to the power 3. Minus 3 raised to the power 3. Result is going to be negative. It's going to be minus 27 by 64. So that's it for today's session. In my next session, we will understand the laws of exponents. Till then, please take care of yourself and have a good day. Bye.